This video demonstrates the effects of extra phone sockets and house wiring on a VDSL connection, FTTN, FTTC or FTTB. In the first test, the DSL link speed was measured at the lead-in cable with the house wiring disconnected. I don't recommend that you do this test unless you are qualified to work on house wiring. The DSL download sync speed was 42.81 megabits per second and the upload sync speed was 11.085 megabits per second. Next, the house wiring was reconnected and the modem was connected to the phone socket inside the house, which is connected to the lead-in cable by 15 meters of normal house telephone cable. The speed at this point was 45.56 megabits per second down and 10.47 megabits per second up. To simulate a second phone socket, this socket was then connected to a 25 meter Cat5e single-stranded twisted pair cable. The far end of the cable was disconnected. Because of this parallel extension cable, the download speed was reduced by about 20%, but the upload speed was only marginally reduced. To simulate a second extension socket, a 25 meter telephone extension cable made out of normal telephone house wiring was connected to the remote end of the Cat5e cable. This resulted in both the upload and download speed being reduced by over 20% compared to the speed at the lead-in cable. This configuration for connecting extra sockets is known as daisy chaining and is the normal practice used for connecting telephone sockets. Not all houses are wired this way. Some houses have all the extra telephone sockets connected to a central point. This is known as star cabling. To demonstrate the effects of star cabling, the 25 meter telephone extension cable was disconnected and then reconnected to the first telephone socket. This results in the download speed being dramatically decreased by 40% and the upload speed being decreased by over 25% compared to the speed at the feed-in cable. In the next test, the modem was connected to socket 2. The 25 meter telephone cable was left connected to socket 1. This resulted in the download speed decreasing by about 25% and the upload speed decreasing by over 30% compared to the speed at the lead-in cable. Next, the 25 meter telephone extension cable was disconnected from socket 1. This resulted in the DSL download speed being about 4 megabits faster than DSL download speed at the lead-in cable and about 1 megabit slower than the upload speed at the. In the next test, the 25 meter telephone extension cable was connected to the end of the Cat5e cable in parallel to the modem's connection. This resulted in the download DSL speed reducing by 25% and the upload DSL speed reducing by about 35%. In the next test, the modem was connected to the end of the 25 meter telephone extension cable to simulate a connection to the third telephone socket. At this location, the download speed was about 2 megabits faster and the DSL upload speed was about 1 megabit slower than the speed at the lead-in cable. For the next group of tests, a 25 meter single-stranded twisted wire telephone cable was connected to the lead-in cable to simulate an external telephone socket connected to the lead-in. The modem was then connected to socket 1 with all other sockets disconnected. The speed at socket 1 was 11 megabits per second slower and 1.1 megabits per second slower than the speed at the lead-in cable. Next, the Cat5e cable was connected to socket 1 and the modem was connected to the end of this cable. At the end of the Cat5e cable, DSL download speed was about 12 megabits per second slower and the upload speed was about 1.5 megabits per slower than the speed at the lead-in cable. Next, the 25-metre telephone extension cable was connected to the end of the Cat5e cable, and the modem was connected to the other end of the telephone extension cable. At this location, the DSL download speed was about 8 megabits per second slower, and the upload speed was about 1.5 megabits per second slower than the speed of the feed-in cable. Next, the 25-metre telephone extension cable was connected to socket 1, and the modem was also connected to socket 1. In this configuration, there were now 4 parallel cables to the line from the node. This resulted in both download and upload DSL speed being reduced by 50% at socket 1. Next, test the effect of using multi-stranded cable. The parallel cable connected to the lead in, and both the Cat5e cable and the telephone extension cable were disconnected from socket 1. The modem was also disconnected from socket 1. A 15-metre multi-stranded telephone extension cable was connected to socket 1, and the modem was connected to the end of this extension cable. Download speed was reduced by 2.8 megabits per second, and upload speed was reduced by 1.5 megabits per second compared to lead-in. Here is a summary and graph of the results. As you can see, the best speeds are obtained when there are no parallel connections, and also when the cable is single-stranded and not multi-stranded. The greatest loss of speed is caused by parallel connections, and the more the number of parallel connections, the greater the loss in speed, and to a lesser extent, the longer the length of the parallel connection, the greater the speed loss. Each parallel connection is known as a bridge trap and reduces the speed because part of the signal travels down this parallel connection, and when it reaches the end of the cable, because it is unterminated, it's reflected back and adds to the incoming signal. But because it is out of phase with the incoming signal, it decreases the signal to noise ratio. And in order to maintain the same signal to noise ratio margin, the DSLAM and the modem have to transmit at a reduced speed. Bridge taps are indicated by sudden dips in the modem's signal-to-noise ratio graph or bit loader graph. Normally, there should be a gradual decrease in signal-to-noise ratio and bits per tone as the frequency increases. These graphs have the normal bit loader and signal noise ratio graph overlaid on top of the graph of the socket with a bridge tap. If your house is wired correctly using the daisy chain configuration, you should be able to avoid bridge taps by selecting the socket at the end of the chain. If this socket is not in a convenient location, or your house has been wired using the star configuration, the only option is to get a licensed cabler in to disconnect all the extra extension sockets. The cabling should not need to be replaced unless some multi-stranded cable has been used instead of single-stranded cable.